All right, let's talk Python. We're going to tackle one of its core pieces, the tuple. Now, you might look at it and think, hey, that's just a list, and you're kind of right at first glance. But it's got this hidden superpower, this one key difference that makes it so important. And once you get it, you'll be writing code that's not just better, but safer and faster too. So what's the big secret? Well, think of it as an unchangeable list. I know, right? Imagine a list that's completely locked down the second you create it. You can't add to it, you can't remove from it, you can't change a single thing. And that brings up a really big question. Why on earth would you ever want a data structure like that? And if you look at them side by side, the difference seems tiny. I mean, look, lists have square brackets, tuples have parentheses, that's it. It feels like just a small syntax change, but trust me, swapping those brackets for parentheses completely changes the game. It has huge implications for your data. Here's the best way to think about it. A list, that's your whiteboard. You can scribble ideas, wipe things away, add new stuff whenever you want. Super flexible. But a tuple, that's a stone tablet. Once you carve something into it, it's permanent. It's not changing. So the big mystery we're going to solve today is this. In a world that loves flexibility, why would any programmer choose the stone tablet over the whiteboard? All right, to really get why that stone tablet is so useful, we've got to get our hands dirty first. We need to nail down the how. So let's quickly build our first tuple. Making a tuple is super simple. Seriously, you just take your items and wrap them in parentheses. So here, we've got a student's info, a name, an age, a major, all bundled up nicely. And notice, you can throw whatever you want in there. Strings, numbers, doesn't matter. It's just that easy. Okay, but here's the first classic trap you're going to fall into. I guarantee it. If you want a tuple with just one thing in it, you have to add a comma at the end. See that? T equals 10, comma. If you forget that comma, Python doesn't see a tuple. It just sees the number 10 inside some math parentheses. That little comma is everything. It's the secret signal to Python that says, hey, I'm a tuple. Now, the good news, if you're already comfortable with Python lists, you're pretty much an expert at getting data out of tuples. It's the exact same deal. You use square brackets to grab an item by its index or to slice out a chunk of the tuple. Super familiar, nothing new to learn there. All right, time for the main event. We're about to hit the one single most important rule that makes a tuple, well, a tuple. This is what separates it from a list. So let's set up a little experiment. We'll make a simple tuple called names with Ali and Hamza in it. Looks harmless enough, right? It's just sitting there minding its own business. But what if we try to change it? Let's try to swap out Ali for a new name, Asad. If this were a list, this is exactly how you do it. You target the first spot, index 0, and just assign the new value. Simple. So what's Python's reaction going to be? Bam! Type error. A big, fat error message. And this is not a bug, folks. This is Python standing its ground, enforcing the #1 rule of tuples. The message couldn't be clearer. Tuple object does not support item assignment. You just can't do it. This right here, this is the aha moment. This whole unchangeable thing has a fancy name, immutability. And here's what you really need to get. Immutability is not a weakness. It's a feature. It's a promise. Python is guaranteeing that this collection of data will never accidentally be changed by some other part of your code. It's all about safety and making your data predictable. So you're probably thinking, but what if I really do need to change it? Well, you don't break the rule, you just work around it smartly. The proper way to do it is to convert your tuple into a list, make all the changes you want to that list, and then convert it back into a new tuple. See the difference? It's a deliberate, conscious act, not some accidental little change. Now, because tuples are so simple and so, well, immutable, Python can do some really cool and elegant tricks with them. Which brings me to two of my absolute favorite features, packing and unpacking. But first, get this. This is kind of mind-blowing. Tuples only have 2 built-in methods, just 2. Think about lists for a second. They have a whole garage full of tools to add, remove, sort, and reverse things. This tells you everything you need to know about tuples. They are lean, efficient data containers. They're built for holding information, not for messing with it. And what are those 2 methods? Count, which tells you how many times something shows up, and index, which tells you where to find it. That's all. They're both read-only operations. You can look, but you can't touch. Okay, so let's put some official names on this stuff. Packing is just the fancy term for what we've been doing this whole time, bundling a bunch of values together into one tuple. Simple as that. And of course, what can be packed can be unpacked. And this is where the real magic is. Unpacking is when you take a tuple and instantly assign each of its values to its own variable. It's so clean. Look at that. Name, age, country. It's way more readable and elegant than doing person 0, person 1, person 2, right? You can even take it a step further. Check this out. Using the star operator, you can pull out the first couple of items into their own variables, and then just slurp up everything else into one variable. And here's the cool part. That rest variable, it becomes a list. So you get that flexibility back right when you might need it. Okay, so we've got the what and the how down. Now it's time to circle all the way back to our big question from the start. Why the stone tablet? Where do you actually see tuples being used out there in real-world code? Well, tuples are absolutely perfect for any kind of data that shouldn't change. Just think about it for a second. Geographic coordinates, right? An X and a Y. You don't want those to accidentally get mixed up. Or maybe a row of data you just pulled from a database. That's a snapshot, it's fixed. Or something like the days of the week. In every one of these cases, using a tuple isn't just a good idea, it's the safer, more logical choice. It signals your intent. And maybe the most common place you'll see them is for returning multiple values from a function. This is a huge one. Instead of messing with dictionaries or lists, a function can just spit out a neat little tuple. Then, whoever calls that function can immediately unpack the results into clean, self-explanatory variables. It's elegant, it's fast, and it's just peak Python. And last but not least, let's talk about speed. Because tuples are so simple and unchangeable, Python can do some nifty optimizations behind the scenes. They actually use a little less memory and are a bit faster for the interpreter to handle than lists. Now, is it a massive difference? Not always. But when you're dealing with tons and tons of data that doesn't need to change, using a tuple can give you a genuine performance edge. So here's the takeaway. It really all boils down to one simple question. The next time you're about to create a list, just stop and ask yourself, should the data in here ever change? If the answer is no, then you don't want the whiteboard. You want the safety, the integrity, and the speed of the stone tablet. You want to use a tuple.